Okay, so today we're going to take notes, do some examples of limiting reactant problems. So make sure you go ahead and pause and take the notes that are on the screen. You go ahead and zoom that out a little bit. There you go. Before trying to, go on and watch more of the video. Okay, so what is limiting? What is excess reactant? Anytime we do a reaction, no matter how hard we try to do the reaction in the right ratio of reactants, right, ratio of ingredients, we always run out of one of them. One is going to run out first. We can't get it perfect. So that reactant that we run out of then would stop the reaction. And if the reaction stops, then you're not producing any more product. So what we say is, we say that the one that runs out, which we call the limiting, determines how much product we can make, because it runs out. There's no more of it. The reaction cannot proceed. The one that we have excess of, we refer to as the excess reactant, or ER. Let's take a look at an example and see how this looks on paper. And you already did this in the lab. When you did this in the lab, you did a single replacement reaction between aluminum and copper 2 sulfate. And I'm not going to go through the whole thing because you still have to write up your, answer your lab questions, but I'll just do this off to the side. You had a piece of aluminum reacting with copper 2 sulfate, and you visually were able to see which one of these two was left over in the end, and therefore which one of these two got used up. And the one that got used up stopped the reaction. Okay, so if you remember back to the lab, did the reaction stop because you didn't have any aluminum foil left? Or did the reaction stop because you didn't have any more of the blue copper 2 sulfate? You could visually see which one ran out. But then you can also calculate which one should have run out, and you should come to the same conclusion. But I'm going to let you finish answering the questions from the lab on your own. Let's look at a different example. It says, if you had 200 grams of silver nitrate to react with 200 grams of sodium phosphate, which one would run out first? So I have to write the equation, silver nitrate, AgNO3 plus sodium phosphate, Na3PO4. That is a double replacement reaction. So we're going to get Ag3PO4. And we're going to get NaNO3. Okay. We do have to balance it, which it looks like we need 3 silvers on the left. And then we need 3 sodium nitrates on the right. And that should be balanced. So we should be good. So how do we do a limiting reactant problem? How do we determine, if we can't watch the reaction happen, which one of these two reactants is going to run out first? Is it going to be the 200 grams of silver nitrate, which I'm going to label right down there, or is it going to be the 200 grams of sodium phosphate? So I also have 200 grams of this stuff. You don't always have the same mass of both reactants. In this case you do, but one of them is going to run out. It doesn't matter that we have the same amount. That doesn't mean that they're both going to run out at the same time. We have to use the balanced equation, we have to use the periodic table, and we have to figure out which one runs out first, and therefore which one is going to predict the amount of product. So what I do is I just pick at random one of those two numbers, this one or this one. Okay, they're the same number, but they're referring to different stuff, silver nitrate and sodium phosphate, and I convert it to grams of the other. Because what I'm trying to figure out is, if I wanted to use up 200 grams of silver nitrate, how many grams of sodium phosphate would I need? Okay? Because this number is how much I have. Right? And this is how much I have. But one of them is going to run out. And so we have to figure out which one it's going to be. So I'm just going to pick at random. It doesn't matter which one I pick. I usually just pick the first one. And I'm going to convert it to grams of the other reactant. I'm not worried about products at all right now. I'm just looking at the two reactants. So I'm going to convert 200 grams of silver nitrate, 2 grams of sodium phosphate. So what would the next step be? I'm going from grams to grams. I have to go to moles of silver nitrate first. Hopefully you guys are starting to get the hang of some of this. And I'm going to go to the periodic table, and I'm going to say that 1 mole of silver nitrate weighs, well, I've got 3 oxygens, 1 nitrogen, and 1 silver. So that should add up to 169.88. Okay. That cancels grams of silver nitrate. Then from moles of silver nitrate, again, ultimately I would like to get to grams of sodium phosphate, because that's what I want to be able to compare it to how much I have. But first I have to go to moles. So moles Na3PO4, and the balanced equation shows me that this is a 1/3 ratio. Okay. And then I'm going to go to, from moles of sodium phosphate, what do you think the last step is going to be? Good. Grams of sodium phosphate. So 1 mole is 163.94 grams. And let me get out the calculator, do the math. Let's go ahead and try that. And we get 64.3 grams of sodium phosphate. And so I'm going to ask you a question here. Is this number how much sodium phosphate I need to react with 200 grams of sodium nitrate? Or is it how much I actually have available to me? Okay. How much? I have 200 grams available to me, right? I need, and I'm going to actually write that, need 64.3. So my next question is, if I have 200, but I only need 64.3, am I going to run out of sodium phosphate? No, I have more than I need. Sodium phosphate is going to be my excess reactant, which then means that silver nitrate is going to be my limiting reactant. And so that's how we determine which one is limiting. Right? So we answer the question, which one would run out first? The silver nitrate, which means the silver nitrate would determine how much of my 2 products I can make. Okay? So we do have another question we can answer based on this information. It says, based on the previous question, how many grams of silver phosphate would you expect to produce? So how much of this stuff would we make? And we want to base that on the amount of limiting. We want to base that on this 200 grams of silver nitrate, because I know that is going to run out. Okay? So let's go ahead and do that calculation. Again, I start with my limiting. So I'm going to make that so you have this in your notes. Start with LR. So 200 grams of silver nitrate was my limiting. I just decided that. And I have to take that to grams of my product, my silver phosphate. So go ahead and set the problem up. Okay, so you should have gotten grams of silver nitrate to moles. Okay, we've got to go to the periodic table, but we already did that for the previous step. So I can just reuse that number, 169.88. And then that puts me at moles of silver nitrate. And then from moles of silver nitrate, I can go to moles of silver phosphate using the balanced equation. So going back to the balanced equation, that was 1 to 3. So 1 over 3. And the last step is going to be to go to grams of silver phosphate. So again, I want to cancel moles. That's going to go on the bottom. I want to get grams. Okay, so that's going to go on top. All right. By the way, guys, when you're putting in your formulas, your units, like moles of silver phosphate, don't write out the words silver phosphate, and don't write it out without the subscripts, just thinking that that's going to be quicker. Because what are you going to have to do to get your grams of silver phosphate? You're going to have to multiply silver by 3. You're going to also have to multiply oxygen by 4, and then add up all 3 of these masses. So if you forget to put in subscripts when you're doing your units, or you're just being lazy and don't put in the subscripts, you're going to mess up your molar mass, and you're never going to get the right answer. So do that. Make sure you include your subscripts all the time. Okay, so let's silver phosphate. I have to go to the periodic table for that. If I do that, I've already done that, and it's 418.58. It's a very big formula unit. And then I'm ready to do the math. So I get 164 grams of silver phosphate produced. Now, I may not actually produce this. If you remember back from our last lab, the steel wool lab, there was a bit in there about percent yield being based on actual divided by theoretical. So if I calculate that I should make this much product, which one of those two is it? Is this the actual yield from a lab, or is this the theoretical yield that I calculated? Okay, right. This is the theoretical yield. Okay. Excuse me. So remember that the big thing from this is to get the theoretical yield, we based that on the grams of limiting reactant, not the excess. The 200 grams of sodium phosphate does not all get used up. And in fact, I could go back and ask you the question, how much is left over of the excess reactant? Okay, if I had 200 grams available and I only used 64.3, that should give me about 135.7, right? So that would be left over. So if I ever ask you that question, it's just a matter of subtraction.